Right. Hello everyone. Hopefully we're live on YouTube right now, for those who are watching from home or wherever they are. This is our 6th and final lesson in the initial C++ module. Just a quick note, obviously we'll be going on to module 2 next, and it will be hosted not here, but up at Mimecast, which is just up the road at City Point. We'll have it on our website on Google Maps, but you will need to RSVP with us on our website so we can get you building passes issued. That's obviously cpplondonuni.com, and I'll just write that when I go. We'll have to offer spoken so I don't get distracted. And also at the end of this lesson there is going to be a test. So originally I was hoping that we'd have a little bit of time for revision, but depending on how much we cover in this lesson we may or may not do. So this will be to sort of just evaluate how much you've managed to pick up from us. So it's for your own benefit.
Is it open book?
Do what, sorry?
Is it open book?
So no, it should be from memory. The rules on it. Well, I'll get into the rules when we get around to doing the test. As usual, of course, we will be going to the pub. Buy this great gent here a drink. That's how I put it. And I think that's pretty much all you need to know for this session. I'll let him take it away. Go for it.
Okay, I have no idea what Tom? Yes, Tom in the hat there just said. Anyway,
Tom.
Yeah, English Tom.
Okay.
All right, good evening, everybody. Welcome. Thank you for coming again. I think I recognise everybody here. Has everybody been before? Nobody's first time this week, is there? No? No. Okie dokie. Well, in that case, I can skip over this. You all know about this already. Join the Slack channel. That means you do it. Grr. That's part 1 of my pre-session announcements. Part 2. Got a bit of a bonus. If you were subscribed to the Slack channel, you would have seen Ollie post about this on Thursday evening, Friday? Thursday. I've forgotten. One evening, anyway. Ollie decided to spend a couple of hours doing a live coding session on YouTube, all about test-driven development. So doing this sort of live demonstration of that using Catch and another library with a funny name. And so yes, it's all recorded, and if you are interested in learning about that, then go ahead. He's done 2 parts of it now. So if you've got a few hours to spare, go ahead and watch that. It's a little more advanced than anything we've covered so far in this module, but if you've been coming for a while, you should probably be able to pick up on most of what he does.
I should probably point out quickly as well is that from the beginning of the first part, you end up sort of discovering Trompe-l'oeil, and not realising that very good documentation is a way to make it properly report errors in Catch. So I'm sort of complaining about the fact it's throwing exceptions and not telling you what's wrong. And by the second video, I've obviously figured it out. So I'll probably detail that in a blog post or something, because it wasn't actually that easy to find how to make it integrate. Anyway, carry on.
I thought you were going to talk for longer.
Oh, I see, I can.
All right, so last week, who was here last week? Everybody was here last week. You guys are awesome. Like the cool group. So we talked about loops. We talked about for loops, while loops, do while loops. In fact, 2 different types of for loops. And then we went on to have an introduction to references, what reference types are. And we talked about pass by reference, how it's different to pass by value, which is the default. So hopefully you all remember that. I know it was a little while ago, but... So this week, we're going to talk about const references and how they're slightly different to non-const references that we looked at last week. And then we're going to go on and we're going to have not a full introduction, but a reasonable introduction to namespaces, what they are, why we use them, how we put code into namespaces. And then, got a little surprise for you. We've come to the end of the basic introductory module, or we will have by the end of today. And at the end of the module, for people who've been with us for a little while will know, we put together a little quiz, which is really useful for us to know how you guys are getting on. How much of what we've taught is kind of sunk in there, and useful for you as well to sort of see where you are. So I don't know, Ollie probably already said this. It's multiple choice. It's online, and you can fill it out, and then we'll email you your results. And Ollie will go through the solutions as well. So he's prepared the quiz. It's actually nothing to do with me, which is quite a good way of doing things, because it means that I'm not biased in what I ask you. To make sure, yes. Well, anyway, we'll get to that by the end of today.
Quick question: will we be doing the quiz in class or?
It's in class, yes. So we're doing it here. Probably take about 20 minutes or so, half an hour maybe. Yeah, and then we'll go through the solutions in the class afterwards. Okay, so last week's homework. This was an awful lot, wasn't it? 5 different tasks. It looks worse than it is. Good. So who had a go at this? A lot of you. Awesome. Who managed to complete all 5 parts of it? 3 of you. Awesome. Well done. So who did part 1? Let's make our way down it. Yep. 2, 3, 4, 5. So 5 was the tough one. That's where most of the hands went down, I think.
No, that was alright.
5 was all right.
I mean, it took a bit of thinking. But
Yeah. Well, that's the idea. So this was a little bit about pass by reference, but mostly about using loops and nested loops and things like that. So, as always, these solutions are up on GitHub. That should be on one line. It was just a bit too long to fit on one line. So you can go to that URL and you can have a look at my solutions. There are many different ways of doing this. You might have come up with a completely different way of doing it to what I did. My solution is not necessarily the best, as we saw last week. I'm not immune to writing bugs, sadly. But we can have a quick look at that now, if you want to. We'll put it to the public vote. Who would like to have a look at my solutions?
Does my vote count?
I think that's almost a semi-majority, half of you.
Put you on the spot.
No. Mine works. I never said this was good. Or you were bad.
Only needs to work.
Yeah.
He didn't even TDD it. It's just unbelievable.
Me?
Yeah.
No. Okay, so it's a pretty simple project. It consists of CMake lists and main. Obviously, if you probably, hopefully, did this a bit more fully than I did. Perhaps you used a header file and an implementation file and things like that. But I didn't, strictly speaking, tell you to do that. So if you didn't, that's still okay. Okay, so let's begin at the beginning. So I asked you to write a function, and read it right here. Write a function lowercase which takes a reference to a string and modifies the string so that every character is changed to lowercase. So here's my implementation of this. This is my lowercase function. Is that big enough? Maybe I can blow it up one more. So it's a function called lowercase. It returns nothing. And it takes a reference to a standard string. So this little ampersand, this is what we were talking about last week with pass by reference. This and means it's receiving a reference to the string. And inside this function, we have a for loop, a range for loop. And this is an interesting one, because I don't think I actually talked about this last week. But in a range for loop, we can capture things by reference as well. So here, we're iterating over the string. So a string is like an array of characters. And we're capturing a reference to each character in the string in succession. So this is a reference to the character inside this string. And then we assign the lowercase version of the character. So this function's standard to 2 lower. It's in the standard library. It's actually part of the C standard library. And if this is a capital letter, a capital ASCII character, it returns the lowercase version of that.
So it's basically used as the foreign character set, as a non-Latin character set, what we say. Or even non-ASCII, I think.
Yeah, I think it's only defined for ASCII, but
I think it depends on the C locale. But yeah, probably.
Anyway, it's fine for our purposes. It's not gonna work for all Unicode, but that wasn't what I.
Those includes.
Yes. Oh, okay. Right. So this brings in the assert. Well, technically it's a macro. You can think of it as a function if you like, which we use for testing. We'll see at the bottom in a minute. C type and C standard def. I can't remember which was which, but I believe this was for these 2 lower function. Sorry?
CC type is too low.
And there was probably something else down there that I needed standard def for, but I can't remember.
I didn't use CC type, I was still able to use too low.
That's luck. Like one of the headers you include.
It may be the case
I
that
just use string and I.
yeah, it may be the case that in your particular implementation of the standard library, this string header brings in the CC type. Okay, but if you were to use a different compiler, it wouldn't necessarily do that. So yeah, we're using standard string, so I have to include string. And IOStream, I don't think I ended up using that, but for a couple of times when I was testing things, I printed out the strings. So I think you could actually get rid of that. That's probably unnecessary.
Follow-up question based on that then is, can you sort of go, so when you're typing in an ID or whatever, and you will type maybe a function which isn't part of the library that you've included. Is there a way to then figure out which library it's a part of? How do you do that? Or is there a website or how do you manage to do things like that?
C-line is actually pretty smart. And if you use a function that you haven't included yet, it will say, do you want to include this header? It'll give you like a fix-it hint, and you can click the box that comes up, or there's a keyboard combination for it as well. So it will. So that's probably exactly why I've got CC type in there. Is it said I use standard 2 lower, and it said, do you want to include this header that defines? That generally, I think, only works with functions in the standard namespace. It knows which their corresponding header is. For other libraries, you probably have to work it out for yourself.
Alt return.
Alt return is the keyboard combination. Thank you.
You can also do a fancy version of std transform.
Yes, yeah, there are many ways of doing this. The idea, what I wanted you to do was to use various forms of loops for doing this and pass by reference. So this is the way I did it. So we capture each character in succession and we replace each character with its lowercase version. For things that aren't capital letters, then it just returns the original. So if you gave it 1, 2, 3 or a lowercase I, you just get back what you put in.
So if you did auto C there, it would copy.
Yes, it would. Yeah.
It would work. It would work. It would not crash or anything like that. It would be useless.
Yeah, and then so if this little ampersand didn't exist, what we do is we copy each character, and then we'd change the copy, and then when we reach the end of this iteration, that would be thrown away. So we wouldn't actually be changing the string itself. So that's why it's important that we capture by reference here. Okay, so that's the lowercase function. We scoot all the way down to the bottom down here. See, I had just a tiny little test case. So this was actually the string I gave you in the example. Just a mixed case. I call lowercase on this string. And then I assert that this string has been changed so that it's equal to this string literal. So this assert macro, I was talking about it last week? The week before? It's just a very coarse-grained way of doing tests. There are test frameworks such as Catch that Ollie was demonstrating that are much more sophisticated in the way you can write tests. Assert is a very blunt instrument that just either it passes or it crashes your program, right? So for something like this, a sort of a short kind of self-contained thing, assert is okay. If you're doing anything kind of larger, developing a library that you want other people to use, you probably want to use a proper test framework. So that was lowercase. Did most people get something along those lines?
Yes.
Yeah, awesome. As I say, there are many ways of doing this. This is just, just one example. Okay, so exercise 2, write a function headline case which takes a reference to a string. Change the first character of every word of the string into a capital letter. Okay, so first of all, if we're given an empty string, we do nothing, right? So string has a member function or a method called empty, which just returns true or false depending on whether the string has any characters in it. So if the string is empty, we do nothing, we just return. Because here we capitalize the first character of the string. So if the string had no characters, then trying to access the first character, that is the character in position 0, that would be an error. That would probably crash our program. Right? So we don't want to try accessing character 0 if there are no characters in the string. Remember, C++ indexes from 0. So index 0 is the first character, index 1 is the second character, etc., etc. So standard 2 upper, you can probably guess it does the reverse of what standard 2 lower does. If you give it a lowercase ASCII character, it's going to return you the uppercase version. Otherwise, it'll just return what you gave it. So we capitalize the first character of the string. That's the thing in position 0. So we can use these square brackets to access the character at position whatever, in this case position 0. So we access position 0 and we change it to the uppercase version. Now we do something a bit fancy. For every other character of the string, capitalize it if the preceding character was a space. So we have a for loop, not a range-based for loop this time, but an old-fashioned 3-element for loop. So this type standard size t, you could use int there, you get away with it. Size t is an alias for, sorry? It's usually an unsigned long int, actually, but it's an alias for whatever type C++ uses for measuring the size of arrays.
And doesn't it represent the largest possible size?
Yeah. So basically, this is just a way of avoiding warnings. Yeah. So if you used int there, you'd probably get some warnings about comparing signed and unsigned types and things like that. But if you use size t, even strictly speaking, size t isn't necessarily the right type. You have to use standard string : size type, but that's so much to type, I just use size t. So we begin indexing from 1. Remember, we've already looked at position 0, so now we're going to start from position 1. And we continue looping whilst our index I is less than the size of the string. And then the third component, we just increment the loop counter. So as I said last week, this is by far the most common pattern for these three-element for loops. You have an initializer, which just has some kind of integer type. The what do I call that third component? The post operation will just bumps the counter, and in the middle, our loop ending condition, we measure against some sort of size. So this is really common pattern for these for loops. So now we say if string at index I minus 1 is equal to, and that's a space in single quotes, so that's a space character.
The number 20, if anyone's wondering. 20 in hex.
So what would happen if you use double quotes?
So a double quote is a string. A single quotes are characters, individual characters. Double quotes is what's called a string literal. So then we'd be trying to compare a single character. So this member access, this square brackets returns you a single character. If you try and compare a single character with a string, it's going to say I can't compare those two things.
It's a pointer to it's a character pointer.
So here we have to be a bit careful because we have to make sure that the character at index I-1 always exists, because we can't access the string out of bounds. But since we're starting our loop counter from 1, we know we're okay, because the position I-1 is always going to exist. So if the preceding character was a space, then we replace character I with its uppercase version. And we continue doing that until we've reached the end of the string. So now here's a question, just looking at this. We've got the whole function on the screen there. What's going to happen if I give you a string of length 1?
It will go and run the line 23 and exit.
Correct. So if the string has length 1, then we're going to pass this test because a string with length 1 isn't empty. We're going to capitalize the first character, and then we're going to get to this loop, and we're going to say standard size t I equals 1, and then we're going to say is I less than the size of the string? So I has been set to 1, the size of the string is 1, so is 1 less than 1? No, it's not. So in that case, we will never enter the loop. So we'll just skip right over all that and exit the function. So this is safe for strings of length 1 and of any length over that. And this little if block up here means that we're safe for strings of length 0 as well.
You could also have not had a string empty. You could have simply put the if not empty, then do the string 0 thing and not have a return. It would have skipped the for loop as well, obviously.
Yeah, that'd be another way of doing it. Okay, so people get something roughly like that? Yeah, sort of, ish.
I think I tried to do the operation of I-1 in the brackets, and it must have been some other error, and then I mixed it up, so then I created other variables to take that value first. But yeah.
So scooting down to the bottom, we can see we've got a very similar test case. We just initialize a string with this is a headline, all in lowercase. Call this headline case function. It takes the string by reference, so it changes the variable that we give to it, and we assert that it's been changed to be this is a headline with all the initial words capitalized, or the initial letters, I should say. So now we get on to the slightly harder ones. Write a function sentence case which changes the first character of every sentence into a capital letter. Sentences are separated by a full stop followed by a single space. So again, we guard against an empty string. And we capitalize the first character. So this is exactly as we did before. So now, this is much the same idea as we had last time, except this time, instead of looking to see whether the preceding character was a space, we look at the two preceding characters to see whether it's a full stop followed by a space. So, because we're looking at the preceding two characters, this time we start our loop counter from 2. And we see if the last but one character was a full stop and the preceding character was a space. So if looking back 2 was a full stop and looking back 1 was a space, then we capitalize what we have. So much the same idea as the last one, except this time we're testing the two previous characters, not just the last one. Does that make sense? Some nods.
Yeah, I just did it slightly different. The main thing was like I initialized the for loops, if statement slightly differently. I had another one.
Yeah, there are various ways to do this. You could, if you want to get really fancy, you could extract these two as a string view and then compare it against. There are lots of different ways of doing this. This was just the first way that occurred to me. Right, so then I wanted to extend this a bit. So exercise 4, write a function sent in case 2, which does the same, except that this time, instead of just a full stop followed by a space, I wanted any kind of white space character and any number of white space characters. So there are quite a few different things that qualify as white space characters. There's a space, carriage return, a new line, a tab. There are probably others. Those are the ones that I can remember.
Carriage return, but not line feed, I'm assuming. /r/n.
Yeah, that would be 2 different white space characters.
Okay. You're making the point of just a /r, right?
Yeah.
Okay.
So this time we do something slightly different. Well, the beginning is the same. First of all, we check for an empty string, and we capitalize the first character. And now things get a bit complicated. So now we're beginning from 0. So we're beginning from the start of the string. And if we find a full stop, so that is if the current character we're looking at is a full stop, then we have this inner loop. So we keep advancing the position we're looking at in the string as long as this condition is true. So we keep looking forward as long as we haven't reached the end of the string and the character we're looking at is some sort of white space character. So this is a little bit tricky because this is our loop counter up here. And the loop counter advances every time we go through the outer loop. But now we're also messing about with the loop counter in an inner loop. Right? So this is quite a bit more advanced than what we were doing. And I used a do while loop here. You could have just used a while loop and arranged things a bit differently. I just basically wanted to show off a do while loop because I hadn't used one yet. So what's the difference between while something and do something while?
Does it at least once?
It does it at least once, absolutely. So this means that we've advanced I, and I, by the time we reach here, I is pointing to something that is not a white space character.
Couldn't you have just made that while I less than str.size and studio space str I++?
Yeah.
Yeah.
I just want to show off a do while loop.
Okay.
Yeah. So there's a possibility that we had a full stop and then nothing after it. Right? So we may have reached the end of the string. So we have to check here. Are we at the end of the string? If we're not, we know we've got a non-white space character that's the start of a sentence. So then we capitalize it. And then we reach the end of the loop. So I is going to be incremented again and checked against the size. So this is quite a bit more complicated than what we were doing in the last case. But, that's the idea behind these homeworks. Right? Each one is supposed to push you a little further than last time. So this is by no means the only way to do this, or even the best way to do it, but it's a way to do it. So we look through the string, we find a full stop character, and then we keep looking forward until we find the next non-white space character, and we replace that one we've just found with a capital letter, as long as we haven't got to the end of the string in our search forward.
I would also point out that this is mostly okay because it's not a massive loop, but generally speaking, altering your I, altering the thing in your for loop, also inside the body, is a wonderful source of creating bugs.
Yes.
That's why I was right now looking at where the scope heads.
Yeah, it's easier. This is just looking on GitHub. If you do this in an IDE, you can actually, if you put your cursor there, it will usually highlight the matching bracket, matching brace, which is really handy for looking at scopes.
But in this case, it'll iterate upwards because it's initialized at the start, so the I will retain the value.
Yes, exactly that. So finally, we get to the most difficult version of it. So write a function sentence case 3, which does the same as this, except that if we have a sequence of however many white space characters, we replace those with a single space. So, again, quite a few different ways of doing this. One approach, probably if you were doing this in JavaScript or Python or something, you could use a regex. If you've got a sort of,
You do a regex in C++.
yeah. And there is a standard regex library that you could use. I didn't do that, mostly because I hate regexes. I find them much harder than just doing things manually. I should probably go and properly learn how to use them and become one of those Perl wizards who just... Yes, anyway. So let's have a look at sentence case 3. This time I arranged things a bit differently. Not because I had to, but just because I wanted to kind of show a different approach as well. So again, we take the string by reference. We do nothing if the string is empty. And this time we have this Boolean variable, which tells us whether we need to capitalize the next character. And we start off, we know we always want to capitalize the first character of the string. So this starts off as true. So we enter the loop. We're going over the whole string this time, so we're starting from 0. And right at the start, if we have recorded that we want to capitalize the next character, then we do exactly that. So right at the start of the loop, we're going to be in position 0. Capitalize next is going to be true. So we're always going to capitalize character number 0. And having done that, we set our little flag to false because we've completed the capitalization.
You could do that with a Gload as well, actually. Or just check if the number's even.
Huh?
You're basically always capitalizing even numbers, no?
Just a start. This start.
Capitalize net for each one. You said, wait, you're only going to capitalize one thing. That's what you're meant to do, isn't it?
No, so for this one we want to do what we did before, so capitalize the start of every sentence, but also replace n white space characters with a single space. So we want to modify the string as we're iterating over it.
Oh, sorry, I see that. I thought the for loop ended straight after that.
No. The for loop
Yeah,
is quite involved. So, having capitalized, or potentially capitalized the character we're looking at, we look to see whether we're at a full stop. If we are, we go, okay, we're going to look at the character that follows the full stop. Well, there's a possibility we've reached the end of the string there. We have to be careful. So if we have reached the end of the string, well, we're finished. We're done. We have to do no more of this function. So we just say return. And return not only exits the for loop, it exits the entire function. Right? Because if we know if we've reached the end of the string, that's it. We've got no more work to do. So we just return from the function there.
Is it possible to maybe get there and for dot to be the last character?
In fact, that was my test case, yes.
Ah, so you won't crash?
No.
Yeah, of course, because you're on the last character, that is the size. Yeah. You never go past the size.
So I could have, for safety, done if I is
greater
than or equal, yeah. Okay. So now, we have this variable that records the number of white space characters. I said space characters, I should really have said white space characters, because we're not just measuring a literal space, we're measuring anything that counts as a white space. So we have this inner loop, we have to give it a different loop count, and we begin from where we are in our outer loop. So again, this is reasonably common pattern when you have inner loops. We begin from position I, and we carry on until potentially we reach the end of the string. So we've got a new inner loop variable now, j, and we carry on going through the string with this variable j until we find something that is not a space character. And if we find something that's not a space, we break, and this breaks out of our inner loop, breaks out of this for loop here. If we haven't found a non-white space character, so another way of putting it, if the character in position j is a white space character, then we increment our space count. Lots of different ways to formulate this loop. This isn't necessarily the best way of doing it. You could change around these if conditions, for example. You could put the exit condition in the for loop itself. Lots of different ways of doing it. This is just an example. So basically, this looks through the loop and counts how many spaces we've got. And now there's a missing comment. Apologies. So now standard string has this member function method called replace. In fact, it has several different forms of replace. We're using the one that changes every character from I, replaces every character from I to space count with whatever string, I to I plus count with this string. This string is just a single space. So we replace characters from I to space count, I plus space count, sorry, with this string. Now we haven't modified I, so I points to 1 after the full stop, right? And having recorded that we've come to a full stop, we know we need to capitalize the next character, so we set our capitalization flag to true, which is what that comment would say if it was there, but it is mysteriously absent. So having done that, we've reached the end of the for loop. I is going to be incremented again. Capitalize next is going to be true. So we capitalize the next character, and we continue on until we reach the end of the string. And so again, I didn't show you all of the test cases, but they're very similar. You can see we've got, for sentence case 2, this is sentence this 1, and then a whole load of different random whitespace characters. And we just want to make sure that we've kept the whitespace character for the sentence case 2 anyway. We've kept the whitespace characters intact, but capitalized the next T and the initial T, and also that we correctly handle full stops occurring at the end of the string. And sentence case 3 is the same. Oh, I left a print statement in there. I should probably have taken that out. We do the same test string, except this time we want all of these horrible, nasty whitespace characters to be replaced with a single space. And again, we make sure that we correctly handle full stops occurring at the end. So that was pretty involved, right? The last one in particular. It's not all that easy, I thought. Yeah.
Can you go back to the code for the sentence case 3?
Sentence case 3?
Yeah.
Yeah, sure.
I was just thinking up to the top. Say, for example, what if the string given the first character is a white space? Would that still work, the first part? Or would it be worth like?
Ooh.
Would it be worth?
I know you may be
if
you might be right just looking at it.
Alpha character.
No, I think you're right. I think I've missed the case where the string begins with some white space.
Yeah.
That's why I started with the for loops and then initially checked
No,
whether
that's a very good observation. Yeah, so this is why just doing these hasty asserts is not a substitute for using a proper test suite and having proper test cases. Because yeah, you're absolutely right. Yeah, the case where the string begins with n white space characters, you'd still want to replace that. Probably with no white space actually. You probably just want to trim off any white space at the beginning of the string.
Is there a built-in string function?
Sorry?
Is there a built-in string function?
No, that would be far too useful for C++. No, there is no built-in trim function. 30 seconds on Stack Overflow will find one for you, but there isn't one built into the standard library yet.
What if you passed a single space character to 2 upper? Would that work?
2 upper, if you pass it a space character, will just return that same character back to you.
I'll also probably point out that this entire body of this sentence K3 consists of sort of fairly individual behaviours. I would actually break these out into their own functions that this then calls to make it much more readable as well. Smaller. The overall body of that for loop would be smaller.
And I'll add more complexity.
No, breaking things out into functions.
Yeah, but then each function will be calling each other function first.
No, not the. Right, I'm suggesting, like, for example, right, this could potentially be a function. You'd pass it the boolean as an argument by reference so that it can update it. But for example, this could be a function. Then this one, finding a full stop. If you want to scroll down to the body of that. But this then represents another chunk of functionality. So I would, to make them more readable.
Yeah, this is definitely not the
I mean, I was lazy to the
perfect solution to it.
remove the duplicated white spaces and then call the function that we defined in before.
Yeah,
And just capitalize.
that's
like needed to. So it was like 5 lines function.
Yeah.
At the end. So yeah, it was. I'm good with that.
yeah. I mean, that would in fact be a much better way of doing it, of course, to reuse the functions you've already written. Part of the reason I did it this way is to show you a different way of nesting these loops, to deliberately lay things out differently, to show you there's more than one way to, skin the poor unfortunate cat. Okay, so that was my solution to the homework. If you got something that was working, well done. If you handled white space at the beginning of the string, then even more well done, because I didn't. So yeah, if that was all a bit quick and a bit weird, then as I say, the solution is or what we've just seen is that URL. We were just looking at it, so you can go there and have a look through. Right, we've got to get on now because we've got a lot to cover and not a lot of time. So, any questions? Excellent. Right, let's have a very quick run through what we looked at last week with references. So, C++ has reference types. We declare a reference with this AND symbol. So we say, normally when we declare a variable, we say its type, the name, and then the initializer. With a reference, we say its type, followed by this ampersand character, this AND. People usually pronounce this as ref, right? So this would be int ref. And in this case, I've named the variable ref, and you always need to initialize a reference. Right? You can't have a reference that points to nothing. Right? So I've initialized this reference as pointing to I, an existing value. The way to think of a reference, the way I like to think of references, is as a new name for an existing variable. Right? So with this first declaration, what we're saying is there is some memory, some stack memory, which represents an int. So it would be 4 bytes on most computers. There's 4 bytes of memory, which represents an int, and we've named that bit of memory I. And this second line is saying we've given that same bit of memory another name, in this case ref. So ref and I are 2 different names for the same thing.
If you were to, I think it was 2 lessons ago, where you should can manually delete variable from memory. Right?
There is a delete keyword.
Yeah. So
Right,
if you were to delete I, what would happen to?
Okay, so what you're talking about there is what we call dynamic memory management. So in that case, you have to create a variable with the keyword new and delete it with the keyword delete.
Okay.
Right? Don't do that. There are much better ways of doing things, and we'll talk about those later in the course. In this case, this is what's called an automatic variable. That means its lifetime is managed automatically by the scope that it's in. So we talked about that a couple of weeks ago, how automatic variables, their lifetime is determined by the scope. So when we leave the scope, that variable is destroyed. So declaring an int like this is an automatic variable, right? And this is a reference to that.
Automatic.
Automatic.
Yeah.
So the absolute key point is anything we do to the reference affects the original variable. They're two names for the same thing. Both these labels refer to the same, in this case, 4 bytes somewhere on our stack. Anything we do to the reference affects the original variable.
You should probably point out as well the answer to your question is it wouldn't compile because I is not a pointer to.
So just to demonstrate what I was just saying, initialize an int, we've named it I, named that bit of memory I, and then we've given it another name, ref. We can refer to it by either of these names and we'll do the same thing. So if you use the label ref to change the value, so ref equals 42, this also changes I. So it doesn't matter which label we use. We can use ref or we can use I, and they do the same thing. So this line, this is going to compile perfectly fine. It's going to set the variable equal to 42, and we're going to change it again to 24 instead. We're now going to print out ref. What's this going to print? 24, absolutely. Now we introduced another reference, called ref2, because I lack imagination. And we set it equal to ref. We've initialized it with ref. Right, so this is now a third label for the same bit of memory. It's another reference to I. Right, and we can have as many of these as we want. Now doing this in a local scope as we haven't done it explicitly, but as we've implicitly done here, is not very useful, right? Having multiple names for the same thing in one scope, why would you do that? Not very useful. Why it's useful is for parsing by reference. So, as we saw last week, it wasn't last week, I just copied my slides from last week, as we saw the week before last, C++ uses parse by value by default. Meaning that when you call a function that takes its argument by value, it receives a copy of the thing you gave it. Right? That's behavior inherited from C. C always uses parse by value. C++ does by default. But C++ also, we can optionally use parse by reference, which is what some other programming languages do. Fortran's a notable example. People think Java passes by reference. It doesn't, but this isn't a Java course. So if we declare a function parameter to have a reference type, it means that we can operate directly on some other variable. We don't receive a copy, we actually operate directly on the thing that we pass it. Now, we've just seen an example of that with the homework solution, but just to briefly go over it again, we've got this function say hello, and it takes an argument, that's a reference to a standard string ref, and we've named it name. Now, just as we just seen in the homework, we modify name by prepending hello to the start of it. So now I'll create a string named me, and we pass this variable to the function say hello. Say hello takes its argument by reference. So when we change name in here, name is now a different label for this same value. So when we modify name inside this function, it's modifying this variable here. So when we print me, it's going to print hello Tristan. Absolutely. Awesome. That was last week's covered in 5 minutes. So yeah. Yeah.
So when you're passing me, which is passing me, which is a string,
Yes.
it didn't need to be a reference to a string.
So here,
that was the string itself, right? That's the original string in a variable, which is a standard string type.
so the variable me has type standard string. So me is not a reference.
No. Yes. And you pass that directly into that function.
Yes. So we pass by
So you don't
reference.
need, so that was the question, was that when you have a function which is saying that you're passing reference to string variable into the function, you don't need to pass it a variable which is a reference.
No. So
As
When-
in
when
this
you- when you-
weird way to say it, but that's how I was thinking about
I
it.
know what you mean. You don't have to do anything to me to say I want to convert you to a reference.
And then send it.
No,
Think of it as an
you
assignment.
don't have to do that.
Think of it as an assignment. When you demonstrated earlier how to just declare one, right? You did like int and equals some
Yeah.
concrete object.
So this
That is just doing an assignment.
is
Name
initializing this reference with this thing we've
Why
passed.
we pass it.
equals- internally it's
Oh, I
doing
see.
name equals
So you
name.
don't need to do it beforehand and then pass it. That's what I was thinking last week.
You can pass a reference.
I mean, you can, but you don't need
Yeah, you could. And all that would do is what we just saw at the end of the last example, where we declared what appeared to be, we were initializing a reference with another reference and creating a third name for something. Okay, so that was last week. Oh, there's an error on my slides. Hang on a second. All right, let's try again. So const references. So who remembers what the const keyword does? Well, it does a few things. Who can remember what we've talked about so far? The const
cannot change
keyword
the value of the
Sorry?
cannot change the value of the
Cannot change, if you declare a variable as const, you cannot change its value after it's been initialized. So after you've created it, that's it, you can't modify it. So this is good, we get some revision in as well. So I've declared this variable, life union everything, and I've said its type is a const int. You could also write int const if you wanted to, some people prefer it. Me, I like things this way. So life union everything is an int that we cannot change after we've initialized it. So this variable has been set to 42, and now that it's 42, we can never change it to anything else. If we try to say ++ life union everything, for example, that would cause a compile error. It would say this thing is const, you can't change it.
Is it legal to just define it and then give it the value 42? So define constant life unit to the
With
and then you assign
No.
value 42.
So if we just tried to put, you can do that in C actually, but you can't do it in C++. If we just put a semicolon here, and then later on gave it its initial value, that you can't do in C++. Right? It would complain that you hadn't initialized the const value. Yeah. It's one of the differences between C and C++ actually. In C you can do it, in C you're allowed one assignment, if you see what I mean. And, in C++ you have to do it in one go.
Won't it complain even if you don't try and give it a number? You have to give it a number now.
Yes, that's what I mean, yes. So when you create it, you have to give it its one and only value. Now here's the thing. We can also declare a const reference. We call them const references. A better way of thinking about it is a reference to const. It's a sort of funny thing of terminology. We call them const references. The references, in some sense, are always constant, that you can't change what a reference points to after you've created it. What we mean is it's a reference to a const value. And when we do this, it means that via that reference, we cannot change the value that we're looking at. So it's a new name that treats that bit of memory as if we had declared it const. So it's right down the bottom of the screen, unfortunately. So here, I'm declaring an int I. This int is not const. And I'm declaring a reference, so declaring a variable called ref, whose type is reference to a const int. And I've initialized this with I. So ref is a new name for this same bit of memory, except that using the name ref, we're conceptually thinking of I via the name ref as being const.
So is I a const now?
No, we haven't changed I at all. We can still modify this bit of memory via the name I. We cannot modify it via the name ref.
I thought they were pointing on the same memory
They are.
address.
They are.
But you're modifying the value of that memory address.
You can modify it via this name, because this is not const.
Oh, I see.
You cannot modify it via this name.
So it's basically like a read-only variable.
It's exactly like a read-only variable. That's the perfect way of thinking about it. So let's have a slightly more involved example. So we'll create an int I. This is not const. We can change it via the label I. So now we create a const reference, which I'll call cref. And we've initialized it with I. So a reference to a constant. So I've probably said this before. We read types in C++, read them from right to left, because, you know, why would we make things easy? So this is a reference to a constant. And we've initialized it with I. So that means that we can't change this value via this name. We can change it via the name I, but not via the name cref. So this is fine. I is not const. We can say I equals 24. That's absolutely fine. Okay. So now we want to print out cref. First of all, is this line going to compile? Yes. This is okay, because printing out the value doesn't modify it, right? This is only reads the value, doesn't write to it. It's a read-only function, so passing it a read-only reference, a const reference, is absolutely fine. And it's going to print... It's going to print 24, yeah? I've intimidated you with this const reference stuff, haven't I? You've gone all shy. Okay. So now we use this const reference, this read-only reference cref, and we try to modify the variable via this read-only reference. We're going to get a compilation failure. It's going to get a compiler. It's going to say cref is const. It's a reference to a constant. We can't modify I via that reference. Okay, so does everyone understand why we get a compiler here? Yeah? But if I'd said I plus equals 1, that would be fine. So now let's try doing things the other way around. I'm going to declare a new variable ci of type constant. So now ci can never be changed. Any attempt to change the value of ci is going to be a compile error. Now here's a little fun thing. We're creating a variable mref, mutable reference, whose type is reference to int. Now note, we haven't said constant. This is a reference to a mutable, changeable int. And we've initialized this with CI. But CI is const. We can't change CI. So if we try and initialize a mutable reference, a non-const reference with a const variable, we're going to get an error. Right? And the reason for this is this type, reference to int, reference to non-const int, is saying it's okay to change the thing that we're pointing to via this name. And that's not okay because we've said we can never change CI. So we definitely can't change this bit of memory via this name. So how can we possibly introduce a new name for the same bit of memory that we can change, right? So we can strengthen const, but we can't weaken it. Is one way of thinking about it. Right, we can create a read-only reference to something that's read-write. We cannot create a read-write reference to something that's read-only. We can strengthen the conditions, we can't weaken them. So unfortunately, we're a bit pushed for time. It's been a bit longer going over the homework than was intended. So I've had to go through that really quickly. But you guys seem really switched on tonight, so I reckon you've all got it. Yeah? Yeah, awesome.
So if you put a const int and nref, bingo.
Yeah, had I said constant here, if I put the word const, that would be fine, because we're declaring a read-only reference to a read-only variable, and that's fine. It's the fact that this is read-write, that is non-const. We're trying to create a read-write label for some memory that we've said can't be changed. So this is actually slightly more useful than the example I showed you before of just creating a new label in the same scope. Occasionally, it can be useful to have an inner scope where you create a const reference. Very occasionally, right? Because it means that in that inner scope you can't change the variable. But in general, as before, the main use for this is when we're calling functions. So just as we saw last week, as we saw a couple of minutes ago, we can declare a function which takes a parameter of reference type. And it's probably no surprise at all that we can declare a function that takes a parameter of const reference type, of read-only reference type. And it means that inside that function, that variable is treated as if it were read-only. It means we cannot change the value via that name. And this is brilliant. Because if we pass by const reference, it means that we don't have to worry about copying. So we said that was part of the motivation for using pass by reference in the first place. But using pass by value everywhere, if we were to pass it, a huge string that contained the complete works of Shakespeare, we don't want to copy that string every time we pass it to a function. That's why pass by reference is a good thing. But on the other hand, when we pass by reference, by non-const reference, by read-write reference, we don't know when we get back from the function whether it's changed the value of the string. We don't know just by looking at the function signature. But when we pass by const reference, we know that just by looking at the signature, we know that it cannot mess about with the reference we pass to it. Because within that function, any attempt to modify the variable is going to be a compiler. So we avoid copying, and we don't have to worry that things are going to have changed behind our backs. For this reason, pass by const reference is I'd say probably, you'd agree, right? Probably the most common way that we pass arguments to functions in C++, right? For
stuff you're going to read.
yeah, so I would say that for small types, built-in types, ints, doubles, floats, bools, those you want to pass by value, right? Because it's essentially free.
I habitually pass by const reference generally as I'm writing stuff, so even if it's an int,
Yeah.
pass it by const reference. And to be honest, it gets you in the habit of doing it, and two, it doesn't cost you anything anyway. Just do it.
For anything else, pass by const reference should be your default way of passing things to functions, right? It's essentially free. That is, there's no overhead involved in copying. And it means that the person calling the function knows that the arguments haven't been messed about with. Right? Pass by const reference should be your default way of doing things.
So does that mean that you tend to avoid modifying the argument that you pass to a function by reference? You tend to avoid doing that.
Most functions only need to read their arguments, right? If the function is intended to modify its argument, like the homework examples homework problems, for example, in that case, yes, take a mutable reference, right? But most of the time, I would say like 90% of the time, you're going to be reading. And in fact, if you're sort of into functional programming and things, it's the argument that you should always return a new value. So if you think about what we did for the homework, another approach, an equally valid approach, would have been to take a const reference to the string and return a new string that was changed to sentence case or whatever the other ones were, lowercase, etc. That would be an alternative way of doing it, which would have had some costs because we, in the end, be creating a second string, copying a string. But on the other hand, again, I say if you're into functional programming and you like functional purity and things, it would have some advantages in multi-threaded environments because we wouldn't have to worry about things being half updated. But yes, pass by const reference is great. And it's how it should be your default go-to way of passing arguments to functions. So I have a little example of this. A function called printInt. And we know, just from this function signature here, imagine this appeared in a header. You'd need a semicolon there. If this appeared in a header, we don't need to know what this function actually does. I mean, we can probably guess from its name, but we don't need to know how this function is implemented. Because just by looking at it, we know that whatever we pass to this function isn't going to be modified. We don't have to worry that, let's say if it took a string instead, we don't have to worry that, oh, perhaps our string is empty when we get back from this function. We know that this can't modify the argument we pass to it. It's not going to copy it. I mean, in this case, copying in is no overhead anyway, but if it were a vector with 10 million things in it, we don't have any copying overhead, but we also don't have to worry that it's been changed. So printInt does exactly what you think it does. Not very exciting.
When you say that there's no overhead, do you mean like literally no overhead, or it's just so small that it's not worth thinking about?
The second one.
Okay.
Yeah.
Actually, there is a constant rep or
A normal
by,
end.
by value.
Yeah.
There is literally no overhead.
Really?
It's a register.
Well, technically, there's function call
So,
overhead, right?
I just tried it in Gogol for the sake of it. If you were exposing a function that took by ref, so say it's a separate library, if you can't optimize it out, then by value is actually cheaper because it avoids doing a pointer dereference.
Yes. For
So by value is cheaper
yes.
than by reference.
That's
If
why I said for small types, for built-in types.
Yes, but if it's internal to your program and you're doing full optimization, referencing does allow aliasing, and it allows the compiler to rationalize it a bit better. character as a reference and it's internal, use one. If it's trivial and it's external, someone else can use it. Consider value types.
So where we are. Where were we? Okay, so we've got this print in function. We declare a variable. I couldn't be bothered writing out life union everything this time. So life, etc. is equal to 42. And then we call the function print int. And we pass it life, etc. Now this is just what we saw before. This is not a const variable, right? This is mutable. We could change this value to 43 if we didn't like Douglas Adams. What happens when we call this function? This reference is going to be initialized with whatever we passed it. Right? In this case, the variable, its value is 42. Right? So, but it's going to be a read-only reference to this bit of memory. So this is what I was saying about strengthening. We can strengthen const, we can't weaken it. So in this case, we're taking something that's non-const and we're looking at it through a const lens. So this is perfectly fine, we're strengthening, right? If we try to do it the other way around, if print int took a mutable reference and this was const and we tried to pass it that way, that wouldn't work. Oh, I thought I had a bit more there. Oh, I'm going to have a bit more because I wanted to show you something else. Ah.
Is that what it's called?
Oh. The formatting is wrong here, unfortunately, because it's come out in the same colours as the comment. But this isn't a comment, right? If I call print int, and rather than passing it a variable, I just pass it, it's called a literal 42.
Pure alpha.
What's going to happen here? The compiler will complain?
I think it would do it fine.
You think it's going to do it fine? Okay, differing opinions. Okay, why do you think the compiler is going to complain?
Because you can reference, because you said at the beginning that a variable needs to be declared before you can reference it.
Mm-hmm.
So that 42, what's 42 in that case?
Yeah. No, I absolutely right in the way you're thinking. But you think it's going to work fine, so why do you think it's going to work fine?
Because I think you're declaring it as you're passing it into the function.
And it's a temporary, doesn't it still be allocated a temporary value in memory?
You've hit upon exactly the right word there, yes. So in a sense, you're both right, because you're thinking along exactly the right lines, is that, well, you're initializing a reference to some bit of memory, so there has to be something that you're referring to, right? But what happens is when we pass something here that is not an existing variable, but is something that is just coming into being, like a literal, perhaps we had a function that returned an int, something that's in C++ terminology called an R value. We can think of it as a temporary. What happens is that it will create, behind the scenes, it will create an int, and this reference will be initialized to that int. But that int will only live for as long until we hit the semicolon. Right, this is something that's a bit strange and a bit magical when you first come across it, but it's what allows us to pass a string literal to a function that takes a const standard string ref.
I'm going to point out it's because it's const that it works.
But this magic of bringing to life a temporary and then, in the terminology, binding the reference to that temporary only works for const references. It It does not work for mutable references. So if that const keyword wasn't there, this call would fail. Right? It would say, well, you can't modify what 42 means. Right? This would be saying, give me a reference and let me change that thing. Well, you can't change 42. 42 is 42.
All literals have to be initialized to
Take an incorrect ref. That would be legal, but that's more advanced.
But why wouldn't it? Because it has been addressed, it has memory address, say, doesn't it?
Yeah.
Technically, it still has a memory
I
address.
can
And
see.
the reference itself, if you then look at the machine architecture, you still have an address to go to.
That's not true. It could be a register. It could just be a number in the register. In sequence register.
Okay.
It doesn't have to be that memory address. L values are guaranteed.
Within this function, it's perfectly legal to say the address of I. Right? Because I is most definitely now value.
That is legal.
Yeah. And it will give you the address of the temporary.
That's because it can
Right,
essentially.
but you know, you're right. C++ could have been defined so that a mutable reference did cause a temporary to spring up. And Strastrup, the guy who invented C++, has an article on his website where he discusses this. And he says, well, he has an FAQ on his website. Basically, a whole list of things are of the form, this is really strange in C++, why did you design
The
it this
10
way?
commandments.
And the reason is basically to avoid surprises, because it looks as if you should be able to modify this thing, but if the thing you gave it was just going to disappear when you got to the end of the function, that would be quite surprising, right? So this lets you read from temporary values but not change them because they're about to die anyway, so what's the point of changing them? Right? Any modifications you make are just going to be thrown away as soon as we hit this semicolon. Right? So in the sort of strict terminology of these things, you can't bind a mutable reference to a temporary value. We can bind a const reference to a mutable value. So this was something that, when I was talking about const references last time we did this, I didn't talk about this thing of temporaries. But like I said, you guys seem really switched on. You know, really know what you so really seem to get this. So I thought I'd throw in that little wrinkle. Okay, I do have an exercise for you. We are really pushed for time, but perhaps we can, since I've been nattering for a long time, perhaps we'll just spend 5 or 10 minutes having a quick look at this. And like I say, you all seem to know what you're doing anyway, so I reckon this will be no problem whatsoever.
As usual, if you need help, just holler. Oh, okay. Relent my laptop. Do you want to do it? You, if you've got a phone, you'll be able to do it on your phone. It's Google Forms, so. Well, actually, you know what I do? Sorry. There's a few questions we have to write in the code, so not a lot. That would be terrible. thanks for live streaming. So it's nice. So thanks for joining us.
Yes, for passing. Except string literals, which are values.
Yeah, of course, because they have program lifetime.
Yeah.
So there's no, yeah.
So he did effective C++. It was great. It teaches you the new stuff as well. So you use some C++. Oh. We'll get to all that stuff. We're just, we're covering those.
Yeah.
This is initial stuff.
Yeah, long C++. It's quite wonderful. One of the hardest things I don't know, you reckon one of the hardest things you've maybe had to teach long C++ really was probably our
I really enjoyed that session though. So I remember we were in the little room over there.
Yeah.
When in particular, Paves was.
He's there.
That was the point at which it clicked for him. I felt, oh yeah, that's done something good.
If you think about it, the funny thing is that pre-C++ 11, you had the concept of PR value really, right? You still had this thing that we just described, where you have a const ref to something, and you can give it a PR value version. And really, the thing that's great about C++ 11 is they crystallized it. So actually, why don't we make this a type you can express? And that brought in move semantics. It was fantastic.
I think it's like the syntax is the kind of mild
I definitely say more expressive. It made me come back to C++ as I looked at it. This is way better than it used to be. But simpler. The non-C++ devs, I think for teaching people, they've got more to absorb now. I think if you're coming back as an existing dev who maybe went away or whatever, then
Question about C++. Why there is no decent way to install libraries? Why there is no package manager? Why there is no? Why does
Do you
it
want-
sucks?
How
answer?
deep is the rabbit hole you want to go
do you
into?
want just a hard answer to that?
I mean, did somebody try to say, okay,
Yes,
this is
there
the
are.
way?
Yeah, it's Conan.
So there's something called Conan, Conan, as in the barbarian, which is been around for like 3 or 4 years now or something. That a lot of people use. There's another one, it's a Microsoft one, VC package. That's
NuGet, actually. No,
no,
NuGet
it's
C
the C sharp one. So
yeah.
VC package is another one that Microsoft uses.
CMake?
Well, CMake is just like a build system.
And packaging. It does do packaging, but it doesn't do distribution.
No, it creates RPMs and things, but it doesn't do packaging in the sense that something like NPM or NPM does packaging.
there's no dependency. It's not dependency manager. Well,
Exactly.
well, it's
But even if it wasn't just there, like a way to have like, a log file that defines the dependency, defines the version.
Yeah,
That is
see,
some
mate,
in
so
a command that you say go and install that.
There
They're
is some,
installed in your vendor file. I don't know whatever.
so I
there's
do
something
this.
that many people want, and there are lots of discussions taking place.
So I use this myself, and the answer to the I use CMake. That defines my dependencies. And when it comes to external stuff, so it could be on GitHub, or it could be something I can download from a repo that's in a tar, or there's an extension to CMake called external project. So my CMake lists script file, if you want to call it that. I declare an external project, and there's a download step, for example, which involves whatever it is, Git, or you can use a Git clone step and clone repo, whatever you want. Check out the tag. And then if it's just CMake based, you can pretty much just build it. You have to define, if you need stuff like link-time optimization, you can't pass your own flags into that. But if you don't care, then pretty much the default generate. And then I can depend on whatever name I give that. So if I download say Google Test based. So I just define it, I decide I name it obviously Google Test, and then I make my executable, add executable, blah blah blah. Add target dependencies, add dependencies, make depend on that external project. And I just have a series of external projects, so Boost is one of them. When those external projects are CMake based, they're painless, generally, as they green screen.
Try changing that.
And they're not CMake based, Boost, I have to define the configure steps, I have to call some Python script to do some stuff, and I have to declare the build step, which I probably just call it make, it's usually okay. And then I have to declare an install step, which I stick it in my build. Within the context of my build file.
Okay.
So you're saying that if you're using a Boost library, you will define it as another project that you can just reference and install.
I choose what I
So
choose.
the
But then how do you, if I was to clone your repo, then would it work for me? Probably not.
That's the whole point. So you just clone my Git repo. You call CMake. That's my goal. CMake downloads stuff from me.
Get it a template function called.
Hire someone.
Okay, I reckon that's about as much time as we can spare for this. Hopefully, yeah. Hopefully, people have had a good go at this. Let's try this again. All right. Our function print string that takes a const reference to a standard string and prints it. So exactly as I just did for print int, except with a string. So of course we need the headers for IOStream and for string because we're using those facilities. So print string is a function that returns nothing, returns void, returns nothing, and takes a single parameter of type, and we read it from right to left, a reference to a const standard string. And I've named that reference str. And of course, all we do inside this function is print out the string, followed by a new line. So now in main, we declare a string, hello world, or hello. It's initialized with hello world. Not a const string, you'll notice, but as I've said a few times now, we can strengthen our const. We can take a read-only view of a mutable variable. So we can print this string hello with no problem whatsoever. What we can also do is create a temporary standard string. So what's happening in here is that I'm creating, so whenever you call a function, if you have any nested calls, it does them from sort of the inside out. So it's, first of all, the compiler is going to evaluate this in a bit. And so it's going to create a temporary standard string with the contents hello again. And then it's going to bind the reference to this string. This is a const reference, so this is perfectly fine. This is what I was saying. If this reference were non-const, then this wouldn't work because we'd be trying to take a read-write view of something with temporary lifetime. But in this case, it's a const reference, so it's going to work just fine. This standard string, this inner string, this temporary string is going to last for the whole length of the print string call. It's going to be destroyed when we hit this trailing semicolon, something called lifetime extension. So this is going to do exactly what you think it will do. It will print hello again. So this, passing a temporary, only works for const references. This is a bit wordy, and the good news is we don't have to do it. We can just pass a string literal. Now, C++ strings are a strange thing. A string literal like this, that is just characters in between quotes. This doesn't have type standard string. That would make life too easy. This is, in fact, a raw array of characters there. But what happens is when we call it like this, it'll look at the type of the argument. It'll say, can I convert this to a standard string? Yes, it can. Because if you're really interested, if you've been doing this for a while, standard string has an implicit constructor which takes a character string, a raw character array. So it does exactly what this line does, but implicitly, without us explicitly. And here we're explicitly creating a temporary string. This does so implicitly. So this is still creating a temporary string that will last, its lifetime will run until we hit the trailing semicolon. But it's creating a temporary string, binding the reference to that string, printing it out, and then when we return from this function, that temporary string gets destroyed. So this is a little bit more advanced than sort of lifetime-wise than what we've been doing. I wish I had more time to go over it. Unfortunately, we're really pushed today.
No, I wonder if it's going to find behaviour to get the .c string completed.
No. Oh, to return a pointer, of course, you couldn't return const char star, return the .c string. That would be dangling. But within this function, you can call C string, C stir, because, and then call any like C string APIs you wanted to, because the temporary is going to last for the whole lifetime of this function call.
Yeah, I mean, strictly it will, yeah. But if C string is just returning the same pointer you passed it, because that still has. Does the const char start?
No, because it will be copied into the strings buffer, and C str will return you the pointer to the
by
buffer.
the standard specification, yeah, of course.
Not even by the standard. I mean, that is what it'll do.
Okay, well, what I'm more saying is if you take a const char, say you take a const char star instead, and you return that.
Yeah.
Does by definition, even though it's an argument, does it still have application lifetime?
If this took as an argument a const char star, well, then you're passing by value.
Now, I know you're passing by value.
Yeah. And you return that same
does
value.
the literal still have application lifetime?
The literal does, yeah. Yeah. But sorry,
You
we're
took
getting
const
away.
char star ref.
We're getting away from the point. We're getting away from the point. So let's concentrate. Yes, this was just a little example to get you to practice writing a function, takes a const reference, and have a little play with temporaries and passing temporaries to const reference arguments. So again, it's a little bit complicated, and I haven't really done it justice, but hey, we've got plenty of time, and if you come back to the next module, we'll have even more fun showing you other ways of extending the lifetime of temporaries.
Is it better to pass char stars or strings?
Strings, if you can afford it. So the problem, it's not really a problem. The downside to standard string is that it will potentially allocate memory on the heap. Right. It does have what's called a small string optimization. That means if you pass it something that's less than, a dozen characters or so, a couple of dozen characters, then it won't go to the operating system. But potentially, it needs to allocate memory. Right. So that's a reason you'll often see overloaded functions, one of which takes a string and one of which takes const cast star. If that's not a problem, right, then use strings because they're much nicer, much easier, well-defined lifetime. You don't have to mess with pointers. Much better to use strings. C++ 17 introduces this new type called a string view, which makes life, in some ways anyway, much easier because it gives you the same interface as a string, but it doesn't have, it always refers to an existing variable. So it's a bit like a sort of special string pointer. But it's nicer to use than raw string literal.
Possibly worth pointing out is through the magic of compilers that we have these days. If you're using Clang since version 5, it can do heap collisions. So if it can see the full lifetime of a heap allocated object, it just removes the allocation entirely. And then it would be free, and they added it in GCC 9, which isn't out yet. What will become 9 should have it as well.
There's no heap allocation.
Yeah, you'll still actually, when you write the code, doing a heap allocation, so you like new and delete, for example. But it just sees, oh, well, you created it here, you destroyed it here, I don't need to do a heap allocation. It sees through the heap allocation. Very clever these days, incredibly clever.
Yes.
I don't know if I've done something stupid, but I declared a constant string variable and just gave it a random string literal. And then I tried to create a reference to that constant string. And it didn't compile.
You can't go from const to mutable, is what it sounds like you've done.
Okay.
So that's exactly what. So here we said that str1 is const, cannot ever be changed.
Yeah.
And now here we've tried to create a new name for that that allows you to read and write. So this is saying this is write only. Here you're saying I want to readable and writable reference. And I can't have like, a readable, writable reference to something that is read only.
Okay.
All right. Let's very, very, very quickly talk about namespaces. So, why do we want namespaces? Well, when we build large programs, in fact, even if we're doing things the right way, when we're building small programs, we want to make use of software libraries. We want to reuse code that other people have written. Right? We don't want to have to do everything ourselves from first principles. But there's a potential problem with this. Is what happens if two libraries that we're using have used functions with the same names? Or types when we get on to defining our own types. And this is in fact even more of a problem. So it's not just, if we try and call one of these functions, well, which version gets called? The problems are even more subtle than this, because if library A has some internal functions and library B defines internal functions with the same name, then when you link them together, you can get in a funny situation where library A thinks it's calling its own internal function, but it's actually jumping into library 2. Right? This is actually a problem. And it's been a problem since the very early days of C. This is not something that's specific to C++. So here we've got two imaginary library headers. The first one defines a function called doSomething, takes an int. So this does something. This is library 1's version of doSomething. This is library 2's version of doSomething. Right? Both of these versions of doSomething are useful. That's why we're including both these libraries. But the trouble is they've defined two functions with the same name. So now in my project, I've included library 1, header defining library 1 and the header defining library 2. We've got two functions with the same name and the same argument types. So now I call the function do something, and I pass it an int. Which version is going to be called here? Can we call that one or that one?
The first one, because of sequence.
Would it be the second one?
You don't know.
Or nothing?
Sadly, it will compile. It might, if you're really unlucky, link properly. But which one it calls, I've got no idea. It depends probably on the order in which you supply the libraries to the linker even then. There's absolutely no way of knowing. If you do something like this is guaranteed to fail. It's not going to work. Right. You've got two libraries with functions that are named identically.
Won't link.
You hopefully won't link. You get duplicate definitions.
You will. You must. They have the same signature.
If they're inline functions, you won't.
That would violate ODR.
Yes, but you won't get a diagnostic. Anyway, so this is a real problem, and it's been a problem since C. It's a problem for most languages. A lot of languages have module systems, like Python, for example, module systems to get around this. C++ doesn't, sadly, yet. Maybe we will. But one very common way around this is to prefix the names of your functions and of your types and everything else you define, to prefix it with a set of characters that are hopefully unique to your library. Right? So if you've ever done any Objective-C, you'll know that everything in Objectives, everything in Cocoa is prefixed with NS. The next step, I think. Yes.
Exactly next step.
Yeah. Or it's CF for Core Foundation, for example. And this is a solution that's used by all C code, and as I say, by other languages, by Objective-C, and some older C++ code bases use this as well. One notable example is Qt, which prefixes everything with the letter Q, because they decided that they own the letter Q. So here's what that would look like. So now, instead of just calling the function do something, we've called it lib1 do something. Library, or rather the author of library 1 has named his function lib1 do something. And the author of library 2 has named his function lib2 do something. And now, hooray, the functions have got different names. They don't conflict. So now we can include library 1, include library 2. In main, we can call these functions. They've got different names. They do different things. All is good, right? No. Why is it not good?
Because if you multiple library one do something, so library two do something, so
No, this is actually fine. This, there are thousands of libraries in the world C libraries in the world that do this. This is a perfectly viable solution, and it's exactly what happens in the real world, right? I've used lib1 and lib2, but in reality you'd use some sort of unique prefix which is hopefully unique to your library. Right.
It's like a bit of a pain to have to do it.
It is exactly, it's a real pain to have to prefix everything, and you have to do this for all your internal functions as well, because if you've used an internal function like within your library that's not meant for other people to call, but it's still a public symbol, you still have to prefix that as well, because it might clash with somebody else's
I think we should make a
library.
That's, that's what you have to do in C, but C isn't great, and we're C++ devs over
Well-
here, so we have better ways.
Exactly. So this is a valid way to solve this problem. But it's annoying because every time we call anything in our library, and this is not just for functions, this applies to types that we define as well, type defs, everything. We have to use this prefix. It gets really annoying to write it everywhere. So C++ has this built-in solution, this built-in way of doing this prefixing for you. Well, not for you. A built-in way of understanding these prefixes, and they're called namespaces. So we can declare, again, I'm going to use the example of functions because that's what we've covered, but also when you define your own types, type aliases, templates, whatever. You can declare them as belonging to a namespace. And a namespace behaves, in some ways anyway, like that prefix we just saw. But now instead of just literally writing out the prefix, we write the namespace name followed by a double colon, followed by the function name. So we've already done this. We've done this loads of times. We just did it in the example on the board. We used something from the standard library. Everything in the standard library exists in the std namespace. So to access things in that namespace, we wrote its prefix, the std prefix, followed by this double colon. So let's have a look at if library 1 and library 2 did things the C++ way. Rather than writing lib1 underscore do something, we've now declared a namespace lib1. And we do the same thing in lib2. So now in our main, we call the function do something, pass the argument 3. And this prefix, this namespace, says we want the version, function name do something that belongs to namespace lib1. It's saying explicitly we want this function. And as you can probably guess, we can do exactly the same and say we want the version, this time we want to call the function do something that belongs to lib2. This doesn't just apply to functions, it applies to user-defined types as well, classes, structs, things like that, enums, etc. So this is saying, I want to use the class string that belongs to namespace standard. So if you've been sitting there for the last 5 weeks going, why do I have to type this std : everywhere, it's really annoying, it's because we're accessing things that exist within the standard namespace. So it's to avoid this problem of clashing names, because if it was just called string, there might be other libraries that define their own type of string. And if we just said string, we could never use those two libraries together.
So string the class, not a type.
It is a type, and it's a type which happens to be a class. A class is one kind of user-defined type. There are other kinds of user-defined types.
I guess we'll get to that.
We absolutely will. In fact, we'll get to it next week, all being well.
So does it make sense to use namespaces then only if you're writing a library?
No.
I mean, if I'm writing something that won't be used by other...
My advice that you will see in about 3 minutes is use name, basically every single function you write that is not main, put it in a namespace, and you'll never go wrong. Right.
Because you might use other people's stuff and they might not be so well behaved. So as long as your stuff's in a namespace, it can't conflict with that stuff you have to use.
So we just saw an example of this, but to declare things within a namespace, we use the namespace keyword, followed by a name. It's the name of the namespace. And then we put a pair of curly braces, and inside those curly braces, we write all the declarations, definitions of the things that belong in that namespace. And the containing namespace becomes part of that function's full what's called fully qualified name. Right? So when we write the definition of the function, we also need to include the namespace part. So remember, we write definitions and declarations separately. If we've written the declaration inside the namespace, then when we write the definition, it has to match the same namespace. So I'm really racing through this. I apologise, we've got a test to get to. We're already over time. So namespace mylib declares a function called print number. And we've put that, so this is just a declaration in the header file. And now in its corresponding implementation file, in the header file, we open the namespace, we put the declaration, we close the namespace again. And then in the implementation file, we do the same thing. We open the namespace. This time we write the definition and we close the namespace again. So the reason I'm showing you this, when you write a declaration in a namespace, the definition also has to mention that namespace, usually by opening the namespace again and writing the definition like that.
I prefer to indent the same.
Yeah, you can. That's a matter of style.
But why is that necessary? Because your header file already said that this is a namespace.
Okay, because what happens if...
And it's being copied into the implementation file, right?
You're working out one outside of it too.
Okay, what happens if the implementation happens to use another header that also defines a print number function in a different namespace? Then when you're trying to define the function, it won't know which version you're trying to define with it. So let's say mylib print number actually just forwards its call to otherlib print number. Right? Then but you've only got the declaration of otherlib print number. When you're trying to write the definition, it won't know which function you're actually defining. So that's why we have to put the definition in the namespace as well.
I will point out that in your translation unit, your .cpp, rather than enclosing it in the namespace declaration, you can write using namespace, my namespace, whatever it is, and then it will resolve it. And then they don't live inside it. So you can using namespace statements. What you want to look up.
Can't you put void namespace double colon and then
Yes, you can. That's another way to do it.
Void namespace.
No, so when you're actually defining the function, you can just...
doesn't go into curly brackets.
Oh, sorry, you mean the definition?
Yes.
Yeah.
So the key advantage, so you might say, well, why is this better than using the C-style prefixes? Because then we just have to write the prefix and a single underscore. This way we have to write the prefix and a double colon. Why is that any better? Surely that's more typing. The point is that when we write things, when we are within the namespace, we can skip that prefix. So if all our code lives within our namespace, then for our own code, we can skip writing the prefix everywhere. It means that our own code internally is much, much less verbose than we would get if we used the C-style prefixes, where it was actually physically part of the name and we had to write it everywhere. Another really important part is that namespaces can be reopened. That is, we don't just have a namespace. One namespace can be spread amongst many header files. And this is exactly what the standard library does. It defines everything within namespace std. So if you look at the header file for string, at some point it will have namespace std, open brackets, the definition for string. And then if you look at the vector header, it will open the namespace std. So we can reuse namespaces, and all those are the same namespace, even if they're in different headers. So again, with apologies for absolutely rushing through everything.
So basically it just adds the headers together.
Yes. Well, sort of. Yeah. Merges all the definitions into one namespace, yes. So it's a very blanket recommendation, and there are exceptions, but for the most part, always use namespaces for everything except main. Main is not allowed to belong to a namespace. because the operating, main is not allowed to belong to a namespace, but everything else, if you use namespaces, you'll never go wrong.
Would you use one namespace per, again, best practices, one namespace per project or multiple namespaces per?
So for simple projects, just one namespace. If you're writing an absolutely enormous, like million-line code base library, you might want to use nested namespaces. So namespaces can be nested. You can have a namespace which is inside another namespace. And then you might want to have your top-level namespace for like your organization, and then individual components might have their own namespace. Again, to avoid things clashing between components then. So I've had to jump around and internal functions. So they're a way of writing functions that are only accessible from within the same CPP file. So it's a really good way of writing helper functions like those. The example, the homework example, if I was doing that properly, I'd put all those functions within an anonymous namespace because we don't need them externally. Didn't talk about this either, but you can have this using namespace declaration. When you say using namespace, it's saying, I want you to assume this prefix when I use a name. So if you say using namespace std, then you can just say string s or cout or whatever.
But doesn't that cause the same problem as before if you have two using two different names?
It's slightly better because it will at least tell you, I don't know which version of the function. If you've got two using declarations and you try and use an ambiguous function, that will at least will be called to compile time. But generally, using namespace is overly broad. It brings in too many names. You're asking for trouble basically if you use using namespace. And using namespace std, which you'll see in a lot of beginner examples, is particularly bad because std is huge and it's got thousands of names in it. Yes.
So is there absolutely no benefit ever to use it like using namespace declarations at all? I do it. It's very rare. Like,
okay, there are. The trouble with C++ is it's giving hard and fast rules. There are almost always exceptions, and one very notable exception is you can use namespace standard : literals, and that is quite useful and quite safe because there are not many things in namespace standard literals. But for the most part, you can do using namespace, but only in a very small scope. So only within the body of a small function, right? Don't just put using namespace blah at the top of your CPP file.
To give one example I think is reasonable. If I declare a class, don't need to know what a class is necessarily. In the definition of that class, I will do using namespace and my own namespace, so that I can have definitions of my class members and not prefix them with my own namespace, because it's my namespace, I know what it's doing. But that's generally.
Never do using namespace blah in a header, right? Because
Never
that's imposing.
so you
this
can
idea.
do a scope.
You can do it within the body of a function, and in that case, that using namespace will be valid only in the scope of that function. Yeah. Again, if I had more time, I'd show you examples of all of these things.
Maybe we can do it next week.
Yeah. And finally, when you have these deeply nested namespaces, it can get really awkward to type out. In that case, you can have a namespace alias. You can say namespace foo equals whatever, and it can be used to shorten. Used to shorten long namespace names. So in that case, instead of having to type long : ns : name, you could just do foo : whatever. All right, that went on too long, much too long. And I was also racing through it, so bad time management on my part this week. I do apologise. That's it. That's all I'm telling you. We're done. We're finished. Module 1 is over. How do you feel?
Ready for module 2?
Ready for module 2? Excellent. I haven't really decided what module 2 is, so if you've got any suggestions, tell me in the pub. I know what we're going to do next week, though. We're going to start talking about defining our own types. We're going to talk about structs, aggregates, strictly speaking. We're going to look at, we're going to start defining our own types. going to start doing some really fun programming. And, we just about got time, I think, because you're all super smart today. We may not be able to go over the answers, so perhaps we'll do that at the beginning of next week, because they do like to check this out. But I reckon we've got time to actually just about have time to look at the quiz. Ollie, do you have the link available?
I slapped it to you, and it's in our CPP London Uni Slack. But I made it. You can type it out easily, so just bung it on the board. If you're not in our Slack channel, why are you not in our Slack channel? That's a
Okay.
nice URL, isn't it?
That is, that's a nice short note. Well, I don't know if it's shorter, but it's nice that you can pick your own names. Okay, so if you go to this URL, it will redirect you to a Google Forms page. I think you have to put your email address in, or
Yeah,
log on with your Google account.
Yes, you can put an email address in so that I can email you back your test results. So some of the questions do require me to actually look at them. And I don't know if that's case sensitive or not. In terms of doing the questions, if you are writing some code to answer a question, you can write your own code in whatever you want, one box, C line, whatever floats your boat. If it's code that you will have to reason about, code that I've put in the test, then don't copy that out, that's cheating. Obviously, the point of this test...
Does this compile and then copy and paste
Yeah,
it?
exactly. Does it go, I know.
Try it with the compiler.
Yeah. It defeats the object. So the point of this test is to sort of, evaluate your own understanding, see where the gaps are in your knowledge, and yes, you're right.
Why is it not right?
Because it's probably case sensitive.
Why?
I don't know. I don't write these things.
I thought web links were meant to be that case.
Well, they can be. Domains aren't, but anything after the slash can be. Yes, it is case sensitive.
Yes, it is. How long is it meant to take?
Well, I said 20 minutes.
Yeah, it's roughly 20 minutes. Maybe
That's 18 at the point I put the URL up, so...
Yeah. Obviously, if you put a made-up email in, you just won't get your test results. I'm not going to spam you, it just goes to me.
That's why something really offensive in the email address box.
Yeah, big thing on mailing it again. I mean, if you use that, you can. Feel free to. I don't really mind. But no, I need to. It will just go for a response and then copy your email out. It's cheating already.
I'm not doing this.
No, it's just not a problem. Is that because someone wants just to point out that like person giving instructions is giving mail? Yeah. Oh no, as the building is evacuating in stages, they're literally evacuating one gender before the other. Wow. Fucking quality there. Yeah, I know, it's the same. Because of the places you play, I would expect that people are just going to say, solve this, they're going to just go straight to the stairs, to be honest. He's going to stand there.
There was a college they used to do, when I had to, they used to have students do evacuations of airlines, but research.
Yeah, but I mean, it's
But, basically, you've got an extra tenner if you run the first out. So the student that caused a matter of fist fights. No one cared.
inside this place where I broke out, like, people are just going to go for it. That ain't going to be anything.
Well, it was the forest here.
There's forest. No one knows that.
Right.
exam invigilator at school.
I know, right?
If anyone needs more paper, raise your hands.
No conferring.
Escort people to the toilet to make sure they're not looking on their phone.
Has anyone completed it yet? Actually, yeah. When someone's completed it, raise your
I
hand.
thought it was in a competition.
Huh?
I thought it was in a competition.
It's not a competition. It's not at all a competition. It's a way for me to gauge how long people need.
Yeah, but some people read slower than others.
Yeah, that's their problem.
Some people check their answers.
Yeah. If you're given 20 minutes, it makes sense to use 20 minutes. Unless you're really, really
No,
confident.
it's for my own. It's for my own reference. Okay. I believe I assigned a total of 21 points to this. Certain questions were multiple points, obviously. Don't guess as well. It's probably one of the most important ones. Don't try and guess. If you don't know it, just don't fill it in. Otherwise, you just
What is it,
maybe
negative
you got it,
marking?
maybe you got it right, and then it doesn't really help because.
What is it, negative marking?
Sorry, do what?
What is it, negative marking?
No, I don't generally do negative marking. I'd rather one just didn't answer it. 'Cause I'm not. You don't get anything. The point is you don't get anything for your score, right? There's no prize here, so it's if you at least that way you can evaluate from your own score how well you've done. It helps us as well evaluate how well we've done.
Perhaps we should do prizes.
Do what?
Perhaps we should do prizes.
All right, you're gonna bring some brownies or something.
Well, Tom makes the cakes, right?
Yeah. Okay. No, I can't really do that. That's like favoritism or something. But I know. Like it's a meritocracy, but still, if you do really well at all of our tests, eventually you might get a job. How's that? And it will have nothing to do with us.
Yeah.
We won't be giving you the job service.
A job as a tutor at C++ Underneath.
Huh?
A job as a tutor at C++.
Yeah.
Underneath.
Pay
That you feel.
you pay a very generous amount of
Sorry?
£0 every time.
It's not maybe rich yet.
It's rich in friendship and possibly beer. Beer doesn't last very long though.
Just wanted to understand your writing here. So that also means I guarantee to satisfy their condition, meaning they will execute they will execute this prompt.
Yes, correct. Oh, okay.
That's correct. Lambdas. And shouldn't this work? So
Oh, I
I
see.
thought you
You've got
decided
that.
so.
No, it's not a pointer. You can't do reference to lambda. It's the same type. Lambda, especially lambda for character. It's not. No, it's got a pointer. It's dereference.
So the thing was, I
Oh,
was
sorry.
Yeah, this was actually working earlier, and I wanted to make this choosable.
Oh, you're trying to create a function. What's my choice? So what's
Okay.
my choice type?
This is here.
Yeah, it's a pointer to a anonymous type. You
Which
can't-
is
It's not going to work
Yeah.
because this is trying to convert sensitive digits. Sorry, touchscreen.
yeah.
This is trying to convert sensitive digits into a function.
Mm.
Only
No,
non-capturing
that's not true. It's converting to a
Oh,
pointer
no,
to the anonymous
sorry,
type.
you are absolutely right.
The thing is, it's not valid though. So stood
These are
for
things.
it's stood for each, right? It's templated. You don't need to pass it a pointer. You just pass it to the type. So you don't need my choice. You just pass it sensitive digit.
So the idea was that I make it choosable by input.
Yeah, okay, I see what you're trying to do. You need type erasure, so you have to have some unstood function. If you want it to be exchangeable, then stood function will perform type erasure. So your conditions are that you always take a char ref. I guess it's a term. So you could use stood function, which obviously performs type erasure to lambdas can be converted to function pointers, but only if they don't capture, which obviously you do. Capture terms. But yeah, still function will solve the problem.
Okay, I'll have to look that up. It's got this strange method that it says it.
I can just type it what you want. I'm going to show you the solution. I can share use function, just a function if you want. It's easy enough.
Yeah, sure.
Right. So obviously first of all we need to remove the header. So we've got this in now. So we actually it doesn't return anything, right? These don't return anything.
No.
Your lambdas don't return anything. And we're going to take the chart ref. And that's consistent with the time. Hey, you can't submit. Yeah. Results. Oh, no, it's double tapping. Sitting in that keyboard. Oh, I think it's doing it. Oh, it's capturing. Okay.
It worked.
Yeah. I also be careful about stood function if you're doing something high performance. It's because it.
Is it just wrapping the function pointers or what's it doing?
Yeah. So yeah, I've actually written my own implementation faster because high performance. What it essentially does is it's all templated. It's a templated function, and so it uses those template arguments obviously to standardise its operator parentheses, and then essentially what it's doing internally, which you can implement yourself, is you have essentially an interface type that implements the operator parentheses, and then a secondary templated class based on the outer template that will then go into say a unique pointer. So unless you've got a really good compiler, it will involve a denomitation. So it will hold a unique pointer to the actual function inside it. Move constructor. The problem is it requires copy construction. So if your lambda captures and move only type, you can't use the function anymore. It has to be copyable. But you can implement your own. I did get approval from my company actually to source the function, so I can actually show you what I did.
Is it on GitHub or?
No, not yet. We have our own company. What's this? SSD. Actually, no,
So I'm trying to pretend it's Python, but I'm still not sure how well this lambda stuff works in C++. So I know.
So lambda is its own type.
Mm-hmm.
It's equivalent to creating your own class. It just generates the operator parentheses. So when you make a class like operator parentheses, they can actually call it. Lambda is just sugar around doing that effectively.
So it always makes an actual instance of this.
It's connected to the type.
Yeah, I was trying to do one on
Which
mine. Somehow it's not.
there it is. It's category.
Yeah.
Then we get into the actual implementation, so you have to practically implement interface, sorry, parentheses, template arguments there, right, parameter pack as you can see. Then we have what implements the interface. This is how you type array. So we have our type name T, okay, which just holding this holds the value, this holds your actual value and put into it the type array. So then we look into the actual constructor template.t. So all packages
Next to me.
stack shape is just like you used it.
Ollie, did you mention this? You're not here next week.
I did at the beginning, but I'll say it again, we are not here next week. We are over at Upper Mine class at City Point, so please RSVP on cpplondonuni.com, because if you don't, I get a very annoyed lobby guard asking me who this person is. I
Yeah,
have to
so
come down and sign you in personally, and it's very annoying.
just in case that wasn't caught on the mic and anyone's watching online, we're not here next week. We're not at our usual location. We're at
So this
City Point, a company called Mimecast that we've met at a few times. So that means that please register on our website, cpplondonuni.com, if you want to come next week, and do it in good time, please. Thursday, Ollie, do you know what we do? What's happening on Thursday? Is it Costa as usual?
check our website, since you'll need to go there to RSVP for next week anyway.
Yes.
It's either a Costa or here, as in the Costa Coffee next door. So it's on the opposite side of the road, yeah. Slightly down the street, pretty much opposite side of the road.
I also meant like, you know, the one we went to the Phil Nash one, that's kind of.
Oh, the monthly
next
meetup.
week,
The
yeah.
next one of the monthly ones is, I believe, the 12th of November. And you register for that on meetup.com.
Yeah,
I'm not
done
sure
that.
where it is.
Okay, so not-
So we sign operator.
Okay, who's finished?
I'm nearly finished. I need 3 more.
3 more minutes.
Yeah, 3 or 4.
You may not have 3 or 4 more minutes because they may come and kick us out. It's 9 PM on the dot.
Well, I'll start.
We haven't had 30 minutes yet.
I'm going to close the test then.
No, but we haven't had 30 minutes. We need 3 more minutes.
Alright, someone particularly wants me to go through it. Who wants me to go through it right now?
I think they're going to come and kick us out.
Who's going to come to the pub? I can do it there. Yeah, I'll do it next week as well, but if you do come to the pub, I can whip through it if you really, really want. But otherwise, next week, we'll go through it. And you'll probably get your results before then anyway. I'm sure I'll do them either.
Do you need to close it?
It's not right, huh?
Do you need to close it?
Close one.
The test.
I think I can see when people submitted. I'll let it be. I'm going to let it be this time as an experiment. It's the intro.
Okay, well,
When is the next class?
so the next class is next Tuesday.
It's always Tuesday.
Well, every Tuesday, 6:30. 6:30.
Yeah.
Yeah.
The workshop is on Thursdays.
But we won't be in this building. We'll be a couple hundred metres down the road. If you look on our website, we'll have all the details on there. Thursdays, there'll be the workshop session that we've said about. As far as I know, that's in Costa across the road where it has been. Again, check our website for details. There will be some homework when I put the slides up. I wasn't quite sure how far we were going to get, but I'll come up with some fun homework involving const references and namespaces.
One last thing as well. I don't know if RSVPing for next week on our website is set up yet, but it will be by 3 PM tomorrow.
Okie dokie.
That's why I was gonna
Thank you everybody for coming.